Anyone work it out? Good? Like it? Okay. That's nice. So, it's really go through that, help you understand algebra. Okay. Remember, we're still doing algebra. We're not getting calculus yet. But we need to have strong foundation algebra in order to do calculus. So, what we have these two forms. And these two forms, we can use them to these two forms, we can use them to describe the same curve. That means that they are equivalent. Okay? So if that's the case, we should be able to translate this to that, or from that to that. Basically, it comes down to is we need to know relationship. So it's 4D. We need to know the relationship between those letters, D, H, K, and A, B, and C, right? And remember, when we go to algebra, we don't care about particular value. That's not something. That's the elementary stuff. Okay, elementary school stuff. What we know here is the relationship. Okay, what's the relationship between different things, and also so that gives us the formula. It gives us the theorem. We can prove something. Okay. Now we have here. We learn how to H is what? Negative B over 2A. And our K?
4AC.
What's that?
4AC.
4AC. You should see that. Actually, you should be familiar here. Right? Over 4A. That, you should see something familiar here. Right? So that's what we have. Now, in order to solve for the zeros function, we set this. We set this to 0, right? Right? Remember, the 0, just this curve, intercept the x-axis. Right? So at these 2 points, we have this equation. What's the name for this equation? No, this is word wrong. What's the equation? This is not function. Once we set to 0, it's not function anymore. It's 2 points. That's called equation. What's that equation? What's the function? What's this one? Huh? We're not talking form. What is this function called?
Parabola.
That's graph. That's not function.
Quadratic.
What's that?
Quadratic.
Quadratic function. Therefore, this equation is called quadratic equation. Okay, that's on the point. Just like linear equation is a point on the linear function, right? Remember that? Same thing here. Quadratic equation is 2 points on the x-axis. Or sometimes we write like this. That's the same thing. We just set them to 0, right?
Yeah, I like that one.
Huh?
I like that one.
Actually, this one is much better, easier than this to find our x-coordinate. So what we need to do is, this is kind of hard. So if we want to do from here, what we can have? We have 1 4b x minus h squared equal to k equal to 0, right? What's the first thing we do?
Substitute for A.
We do what? We move everything to the right except the x, right? Right? That's how we solve for x. So therefore, 4b x minus h squared equal to negative k, right? And what do we do next?
Multiply by 4D.
Yeah, multiply 4d. So what we have is x minus h squared equal to negative 4d and k, right? Because so far here? See, it's much easier this way, right? So all we do now is square root. Once we do square root, we should have what? Plus minus, right? There's 2 possibilities, right? Because if we have something, say, x squared is equal to 4, then x could be
Negative
2 or
negative
2, right? So we have plus minus. That's where it comes from, right? Yes?
You said that we're solving for the x. And to what point, like, why are we
we'll find the solution to the equation, to the quadratic equation, or basically find the zeros of the quadratic function,
Oh, I see. Okay.
right?
Looking for x-intercepts.
Yeah,
Okay.
Yeah. but actually the reason we do that is eventually we'll get down to the quadratic formula, right? Which tell us what is our root of the function based on x squared plus bx plus c, that form, right? But it's very hard to use that form to find the zeros. So we use this form, the vertex form, which is very easy for us to find, to solve for the zeros. So we got what?
Negative
4 d and k, right? And actually, so x is equal to h plus minus 4d and k, right? We good on here? Okay, so what is our h? Minus b over 2a. Now, what is our k?
Oh, that's cool. Sorry.
What is our k? First of all, we know that this is our a, right? Right? Remember we said that? This a is equal to 1 over 4d. Basically what's in front of us, right? So therefore 4d is equal to what? 4d is equal to 1 over a, right? Right? So that gives us 4d is 1 over a, right? And so therefore what we got here is what? Minus k over a, right? You good on there? Okay, what's our k then? What's our k? So let's write this on the front. K is what? 4ac minus b squared over? Right? And that gives us plus minus a to a for a squared, and top minus in become b squared minus 4ac, right? Remember that? That's how we got it. Okay, now we can write this as, and this is 2a, right? Get screwed on both sides. B squared minus 4ac, right? So what's okay?
Actually, you need to go up just a little bit. Can you like pull back?
Up?
Yeah, no, we're good. Okay.
Okay.
Wait, how did you get the? How did you get rid of 4a squared?
Because
You squared it.
square root.
Oh, okay, sorry. Yeah.
Yeah, and we actually assumed this. We assumed a is greater than 0. Otherwise, we're going to do different. We're good here? Not yet. We haven't got to the formula yet. We haven't put them together. How do we put them together?
Put them together and put them on the
2a on the bottom, right?
Yes.
Minus b plus minus b squared minus 4ac. Right? So that's our what?
Quadratic.
That's our quadratic formula.
So,
How many quadratic
Huh? What's that?
How many quadratic formulas do we have?
We only have one quadratic formula.
So what's the
The other one is an
equation?
what's the difference between a formula and an equation? I think should be the question.
Oh, equation has to, we set them, this is equation. We set the whole thing to 0. That's the equation. Okay. And this one is a formula. Right? This is a formula for you to find the roots. We are not really solving for anything. We just have the formula and set to the root, find the answer, right? That's called formula. And when you have set this thing to 0, that's equation, the equal sign here. Right? And if we use y equals to that, that's function. Right? Remember, for the function, x called independent variable. In this case, x came from negative infinity to positive infinity, right? So this x has the freedom to choose any value in the domain. But once we set to equation, this x is fixed. We cannot take to any value it wants. Now that's fixed. Okay. So now this x means the x intercept point either here or there. Okay.
What is the ax squared? Is that a formula?
Which one?
Ax squared plus bx plus c.
Oh, that's just a function.
Okay.
See, that's a function. There is a function. Y equal to ax squared plus bx plus c. Same thing, because here x can change.
Yeah.
Can change. And every x give us a y, okay? All right. So we good on this one? We all good?
Yeah.
Now I'm going to look at something, the properties of that function is, if we have something like this, this is our h and k, right? So this is our k, this is our h. So our domain is what? Our domain? Negative infinity to positive infinity. What is our range?
Negative.
Well, it would be
K.
A.
From k to infinity. Yeah. Right? Right? We're good? So that, okay. Because we have this function now. It's different from linear function. Linear function, our range is from negative infinity to positive infinity. Right? But not this. Because we have no values down there. Below k. Everything is up there. Right? Okay. Now we see that we have the situations, either we got this, which have 2 zeros. This have 2, we call unique. Unique zeros. Because those two values are different, so we call it unique. Or we have this kind of situation. This is called double zero. And because we only have one value, but actually it's 2. There's 2 zeros for that. And what you're going to have this.
No zeros.
No what zero?
zero, real zeros.
No real zeros. Perfect.
Same thing, right?
No real zeros. But what happens to the complex?
There are two complexes.
We have 2 complexes. So that got down to is, what is that number? Because in real life, we're only dealing with so-called real numbers. In real life, we don't have any imaginary numbers. But imaginary numbers give us the tool to describe real physical phenomena. Okay, if you ever do design any electric circuit, just any simple electric circuit, and we can use complex numbers to analyze the characteristic of that circuit. Okay, and our digital communication, which is what the cell phone uses, is also based on complex numbers. So even though we don't have those numbers in real life, but we can use that as mathematical tools and to study the real physical phenomena and be able to actually describe them. Okay, so now we have this case. Say if you have this function, y equals to x squared, right? Okay, this we know that is this. And how much? What is our 0 here?
On the origin. 0,
Yeah, we
0.
call that
Origin,
what kind of zeros?
1,
No, this is one value, but there's 2 zeros. What's that? Double zeros. Because if x squared is equal to 0, then x has to be 0, right? But there's 2 here because this is squared. This is different from this. This is different. This is different from this function, right? And this function, you x equal to 0, that's have 0. But this is called single 0. This is double, okay? Because I have x squared on there.
yeah.
These two functions are different, okay? Yes?
Maybe that's more fun.
Sure. And now what happens if we do this? Now here is negative 4, for example. So this, how do you write the function of this? By moving it down by negative 4. Remember transformation of functions?
X squared minus
Y is equal to
x squared minus 4.
negative 4. Shift down by 4, right? Now if we set this to 0, what we have? X squared equals to 4, then x equal to 2. So you find this is 2, this is negative 2, right? We still have, see, we have 2, no matter what. In this situation, we got 2 zeros, but they all have same value. Here we got 2 zeros, but have different value, okay? Now what happens to this case? This is 4. How we write that?
X squared plus 4.
Y equals
X squared plus 4.
plus
4.
4. Now, that's the interesting part. If that's the case, then what's our x? So negative 4 now, because move 4. Let's do that. X squared plus 4 equal to 0, so therefore x squared equal to negative 4. But there's interesting here. What's our x? Right? Because there's no real number for this.
It's imaginary.
Because any real number multiplied by itself always positive, right? Any real number. So this is something new. This is a different number, okay? And this we call it imaginary number. So we got x equal to plus minus square root negative 4, which should be
Minus 2i.
2i, right? And our I is what? I is square root negative 1, right? What's I squared? Negative 1. And I to the third minus I, right? I to the fourth 1. What's I to the fifth? Square root negative 1. I to the sixth negative 1. 7 negative I, fourth 8 is what? 1. So we see that there's a pattern to it. Square root of negative 1, negative 1, negative I, 1. Square root of negative 1, which is our I. So I, negative 1, negative I, 1. It'll keep forever, but have that pattern, okay? Every fourth will come back. So every fourth will come back. That's why on some problems we're trying to solve. Say 41, what do you have? This is what? 40 times I, right? What is I to the 40?
Let me tell you about it.
Okay.
It's gonna be.
Why?
It's gonna be 1.
See why? Because why?
Because 4.
40 is
Divided
the
by
multiple of
1 times 1 times 1 times.
40 is a multiple of 4, right? Every 4 ends up the same number. So this one becomes 1 times I, that's I. Okay? So that's where you see the problem when you're dealing with these numbers. They give you a pretty big power. But as long as you can break down to 1 has the multiple 4, then we just deal with the rest. Okay? So therefore you can do something like this. I to the 243 give us what? I to the 240 times I to the third, right? What is I to the 240? 1, because this is multiple 4, so it's 1. What is that? Negative I. So therefore it's negative I. So all that can be simplified. So it just goes to I, negative 1, negative I, and 1. Okay? That pattern. We good on this one? So now we're going to check on something we call complex number. So this, right now we're dealing with imaginary number. We say complex number. Complex number write as something like this. Say 2 plus I. We have a real part. We have the imaginary part. That's called complex number. Okay? So complex number includes all real numbers. Remember our number set? We start with counting, right? Next, our set become bigger. The set data number become bigger. What's the next one? Huh? What's the next one?
Whole.
Whole. We add 0 to it, we get a whole. And next one? Integers. And rational. So we got bigger and bigger. And real. And
Irrational.
no.
Complex.
Complex.
Why not?
So why don't we say imaginary here? Because our set is getting bigger, okay? So complex has to be includes real, right? Imaginary number does not include real. So every time it's getting bigger, that set number becomes bigger. So, yeah. Okay. So now for this one, it has something interesting. Is how do we multiply this? 2 plus I times, say, 3 plus 2I. How do we do that?
Like normal.
We use,
Math. Oil.
that's called use distributed property, right?
Sadness.
Right? The technique is called FOIL, but the property is called distributed property. That means we can 2 times 3, 6, 2 times 2I, 4I, I times 3, 3I, and I times 2I give us what?
2I squared.
Negative 1, right? I squared is negative 1, right? So therefore we have what? 6 here, 4I, 3I, 7I. This minus 2 and give us 4 plus 7I. So that's how we do that, okay? We good on this one? So it's pretty much review. But what happens if we're dealing with this? Say 1 plus 2I, and here is 3 minus 2I. How do we simplify that? How do we multiply a complex number give us real number?
With another I.
You know, another one happened. It's got I here. Huh?
I can't remember what it's called
You'd
though.
have to do you'd multiply the top and the bottom
By what?
3 plus.
3 plus 2I.
And that's called something.
Yeah.
But I can't remember what it's called. It's got a word.
Yeah, it's
Math
very
here.
well.
But I can't remember it.
Okay.
No.
All right. So, here, this from this, A plus IB times A plus minus IB give us what?
1.
A squared and
Plus
what's that?
Plus
B squared.
Plus B squared. Okay?
what?
Yep. And you can verify it. A times A is A squared. this is that's famous one to get to the real number. You have to use this to get the real number. Otherwise, you won't get real. Okay. So what we do is what? A plus IB, A minus IB give us what? A times A squared. A times I, B, I, A, B. This times that is I, B, A. Then next minus I squared B, right? B squared, right? You good here so far? So these two cancel, right? These two cancel. So what's left is negative I squared B. What is I squared? What's I squared? Negative 1 times negative positive. So A squared plus B squared, okay? So that's the only way we can get the two complex numbers to multiply give us real number. This is the only way. And yeah. Okay, so that's why we got to here. What do we have? So what's on the bottom? What's on the bottom?
9
9 plus
plus 4.
4. Good. Top. 1 times 3, 3. 1 times 2i, 2i. 2i plus 3, 6i. And 2i times 2i give us what?
4i squared.
Which is minus
Negative 4.
4. And now on the bottom, 13, right? Right? On the here, our real number, 3 minus 4 minus 1, right? Plus. Okay, good? All right. So, here I want you to do some homework. On this one, I want you to go over page 19 through 29. 19 through 29.
Page
19 through 29, okay? And this one I'm going to ask you to work it out, not multiple choice for you.
No.
Just do it as a problem and solve it, and okay, solve the problem.
Wait, 19 to
19 through 29.
if we got one of them wrong, right?
No, everything.
If we got
Everything, but you have to do it. You have to show your work. So it's not a pick of the. It's not a multiple choice. Okay, you have to show me your work.
Sorry.